kind of hefty.
Is it the front go back slightly so there's a distance between you?
What? Who? Oh, well,
Yeah, you.
Option is for us to
Oh,
move
yeah,
back.
like that.
So, these little devices are embedded in a field somewhere, monitoring crops, or it could be structurally, it's used for structural health monitoring. So it could be out in the North Atlantic, pinging data about cracks or delamination in a wind farm, and there's no Wi-Fi within range, and there's no power socket within range. These things are so power hungry and so energy hungry. You can't afford for that to be the case for these sensors because they're in remote locations. So you need to develop devices that have very lean chips on board. And in some cases, the new generation of Qualcomm chips, they're talking about 20 years between charges, okay? Or no battery required because they use energy harvesting, the sunlight movement, and that's fine. So they don't need to be powered, and they don't need to have 4, 5G, all that sort of stuff that we humans love to watch movies. No, just a little teeny packet of data pinging back information, and that's the low power wide area network, the LAN, which is, it needs to be out in these remote locations, nowhere near a 5 or 4G tower, nowhere near Wi-Fi. Does that make sense?
Yes.
Okay, good.
Well, I was just going to counter.
Oh, please, absolutely.
Um,
Get the debate going. And then we'll move to questions.
Yeah, so my initial assumption was that, but does anybody know how much data I'm taking a week just with X, Y, Z and the temperature? And
is it very small? It's very big.
So over 2 gig a week.
Whoa. I mean, that's well beyond the capability of the Sigfox.
Yeah,
the LoRa.
that's right.
Or it's going to be very expensive.
Yeah, for Sigfox, for the LP1 range, you're talking about a lot of devices are quarter of a meg. So if you think of a smart meter, which is a typical candidate for this technology, they are optimized to do quarter of a meg, and they do a reading possibly a day and so on. It depends how much data you're churning out, but that's why also it's important to have a blend of technologies, because what you may use is the Wi-Fi function in your house to transmit the bulk of that. But then on your watch, you've also got a button that says, actually, I need help. But that doesn't use much data, and you're away from home. And then, so this blend of technologies, and it's absolutely the case that there's a use case for each technology. And it's not a case that one's better than the other. It's just that one's great for that particular application you need to build.
I think you also find there's a relationship between intelligence and amount of data. So
you're within range, just keep it attached.
We're in range.
It's
It's not 40 kilometers.
You'll pick it up, no problem at all.
So if your device was more intelligent, it might not need to do 2 gigs, because it would be analysing what you're doing and going, right, you're sitting now, you're doing this now, and only putting out the anomalies. And that changes that relationship.
So you have this, is it Luna, the new language, and it's doing more of the computation on the device, which is then ramping up the needs of power. But yeah, you need the answer at the edge, right? I wonder when I'm playing the violin or break my finger again.
Your watch is wondering what you're doing, right?
So Luna is, I haven't come across Luna. That's an optimized OS for edge devices, right? Or
yeah, so I would take my Angel sensor to my Angel Android app and do the computation there, signal processing. I could delegate that to the actual wearable.
Okay, Angel, by the way, is an open source fitness device. So it's a fitness tracker like I'm wearing a Jawbone. They're proprietary, they're locked down, as is, what's the other really popular one that everyone has? Fitbit. So this is an open source version, so you can just go out and hack it and you can shunt the data around, right? That's what Angel is? Yeah. Okay. Yeah. You're wearing one, are you?
Yeah. Got an Angel.
Oh, there you go.
Two open source hardware software.
Whereas I've got the proprietary corporate version, the Jawbone up. Ooh. So, questions? Give it the program. How about you? Wearable technology?
A watch.
Yeah, you don't.
No.
Well, it doesn't run out of batteries as often as mine does. Questions?
Is there a regulatory framework for these networks, like with cellular networks?
In what way? Are there some okay.
Spectrum
Yes.
license, basically.
Yeah, so basically you do have to comply to elements of the radio standards. So whether that is the license or the spectrum in the country you're operating in. So for instance, some of the developers in Singapore say you've got to lock the device down if you're going to sell it in Singapore because the authorities won't approve it if you can hack a link. Well, that's kind of against what we're trying to do. So you've got issues, then you've got around, you know, the amount of times you can send a message. So there's some cycle restrictions around that. So that if a device is sending 100 milliseconds of data and it can't succeed, then there's, I think the formula comes to 9.9 seconds before you can retry. And if you break those rules, then you're going to get in trouble with the authorities. So there are those restrictions which are more governmental, but then if you want to bring your data, your device onto an operator network, then you've got to go through a certification program, and that then certification program will take time and money. So some of our devices for Sigfox have to be approved. For the Law Alliance, it has to also be certified. So these are ongoing. So yes, there are.
Gavin, at the back, aren't you involved with this sort of medical device, IoT? Have you been kind of roped into any kind of...
I was, and Toshiba kind of got out of that field, unfortunately. So I'm working in ultrasound now. But yeah...
Are you looking at blockchain or decentralised or anything?
I must admit, actually, it's not something I've considered before, but in terms of medical data, so it could be wearable data, but actually one of the things people are talking about is, you know, patient power, and kind of actually kind of giving people the power of kind of decision and information. But part of that is, you know, say, you know, CT scans or whatever else and things like that. But perhaps integrating automatic analysis algorithms and things like that. But actually kind of keeping track of that data in a way you can share it with just the right people and not, you know, have it subverted. So, I mean, I don't know, you've got the cogs whirring actually on that, so that's a potentially interesting application.
So we've got a couple of Garys in the room. I'd like to, sorry, go ahead. I'll come back to you, Gary, and ask you because you're quite involved in your specific project. And there's another cybersecurity Gary in the room. Still out there, he is, talking about locking down his edge devices, but please go ahead. Sorry, can you introduce yourself as well to the room?
So, my name is Neil Stevenson, I'm a software developer. And actually, it was a cybersecurity question. It was what mechanisms are in place for securing Wi-Fi credentials?
So we obviously, there's an encryption, there's AES encryption on the device, so all the data that's sent is encrypted. Then there's also some other security around TLS 2.
It's how you store the keys. Key storage.
Roberto, do you want to give some input?
So now we have another way to store the keys with the flash inside the device. So for some way you store the device and try to read the flash, you will be able to duplicate the device. But then we will probably create a middleware, as Francois said, so we will have a way to identify that the device has been cloned.
I'm not concerned about the device being cloned, I've been more concerned about the Wi-Fi passwords.
And patient data, for goodness sake, if you're talking about patient records being hacked, amended, shared, removed, that's really scary.
Can
So
I
how
come
can we
back
solve
to
that?
this thing about
Yeah.
medical histories going on the blockchain? Because a while ago, Estonia said that all their medical records were on the blockchain. And at first sight, blockchains are a terrible place to put personal data. Personal data is like toxic waste. You don't want to store it because it becomes more and more dangerous over time as it can get linked into more and more places. Fortunately, that's not what they're doing. They're using the blockchain to record access to the data. So it means that rather than keeping the data there, they keep the history of the transactions around the data on the blockchain, which means that people can go back and see who has looked at their data. But it's Not that they're MRI.
That's a really important nuance, because I didn't know that. Oh,
Which
okay, that
really
makes a
big
lot more
difference.
sense.
And it
Yeah.
changes that privacy security.
This seems like a really important point, thank you. So are you saying that blockchain is being used as an auditing tool?
Yes.
Thank you.
It's a way to audit acts.
That is a critical definition.
Going back to this regulation, early in the financial services world, when the mainstream came in and said, yeah, we need to regulate this Bitcoin or the clones of it. I went, no, the core feature is regulation, it's self-regulation. And I think all these other projects have to strive to find some form of self-regulation, whether it's in healthcare or the sensors in farming. That's what we're pioneering. These haven't been established